If we want to be able to do math with a number, we need to make sure that we store it as a numeric data type. We can't do math on strings. Recall the assignment operator. In this statement, we're creating a string 1 because the 1 is enclosed in double quotes. It could also be enclosed in single quotes. The string is stored in memory, and the assignment operator creates a variable name a to refer to that string. We could also make an assignment operator for b, setting it to the string 2. And then we can verify the type of each object by using the type function inside a print function. We'll go ahead and run this. And we see that both variables point to strings. If we try to do math on the strings, for example, if we want to print a plus b, we might expect the result to be 3 because 1 plus 2 is 3. But because these are strings, they're not added together but concatenated, meaning we took the number 1 and placed it right next to the number 2 and printed out 1, 2, or 12. Definitely not the right math answer. Instead of storing these as strings, we need to store them as a numeric type, and we do that by taking off the quotations. So a equals 1 creates the integer 1, stores it in memory, and creates a variable named a to refer to 1. We'll do the same thing with b, and try running the program again. This time the type of both objects is integer, and the result is what we expected, 1 plus 2 equals 3. Later we'll talk about all the different operations you can do with numeric data types. There are 3 basic numeric data types in Python. The first is integer that we've already talked about. The neat thing about Python is that integers can have unlimited size. There's no need to talk about long ints and things like that. If we create a really big integer, a, and then maybe multiply it by itself and print the result, we see that Python can handle a really big number. And with Python, the result is precise. You don't need to worry that this was rounded off or approximated. And let's check that a really is an integer. And indeed it is. The second numeric data type we'll talk about are floating point numbers, or floats. Floating point numbers are basically numbers that have a decimal part to them, like 2.03. If we run this program, we can see that a is type float. Notice that we didn't have to declare that a was an integer or a float or anything else. Python just figures it out from the context. Internally in the computer, floating point numbers are stored as fractions, and they are actually only approximations of the actual number. For most applications, that isn't a big deal and we won't even notice it. But if you're dealing with numbers with a lot of precision, and you need very accurate calculations, you need to keep that in mind. We can do a quick demonstration of this problem though. Suppose a equals 0.1 and b equals 0.3. We can print out these values, and we see internally a equals 0.1 and b equals 0.3. They're both of type float. But remember that these are really approximations. Even though we set a to equal 0.1, inside the computer, 0.1 is not really represented exactly as 1/10. If we create another variable named c, and we want the value to be equal to 3 times a, we would expect c to be 0.3. But if we print out the value of c, we get a surprising result. A is 0.1, b is still 0.3, but c is only very approximately 0.3. If we tried to compare b and c, Python would tell us that they're not equal. Again, this usually isn't a problem, but something to keep in mind. Remember that in Python, integer data types can represent any integer value, regardless of how large they are. But float data types have a limit. We can represent very large numbers using exponential notation. 2e plus 100 means 2 times 10 to the 100th power, or the number 2 followed by 100 zeros. Again, we'll print out a, and we'll print out its type. Python has no problem storing a value with even 300 zeros. But if we go up to a number with 308 digits, we find that Python gives up and just calls this infinity. If we make this a negative number, then Python considers this to be negative infinity. The final data type we'll consider is the complex number data type. Remember, if we say a equals -2, that's just an integer, but we can add a complex part to that, writing the complex number just as we would in math, -2 plus 3j, and Python recognizes that that must be a complex number. Don't worry if you haven't studied complex numbers in math yet, we won't use them in this class. But if you're using Java or C++, you won't find it so easy to represent and do math with complex numbers.